Hello, everybody, and welcome to the FOSS Virtual and Augmented Reality Talk with Tim Jakob Bornecrantz. Jacob works for Collabora with graphics and virtual reality, XR lead at Collabora, and a member of the OpenXR working group. He has worked with Linux graphics since 2006, starting with Tungsten graphics and moving into VMware. In 2013, he, along with a friend, started the OpenHMV project. Then in the spring of 2019, was involved in launching both Monado and OpenXR at GDC. Please welcome him.
Thank you very much. As I said, I'm Jakob Bornecrantz. Today, this is what I'm going to talk about. I'm going to give a short introduction to what AR and VR is, talk a little bit about OpenXR, then the Monado project, going in a little bit onto technical details there for those that are interested, and some more status on Monado and a little bit on OpenXR as well, and then wrap the whole thing up. Reintroducing myself here first. Jakob Bornecrantz. These are my contact links. I will upload the PDF somewhere so you can get all of them linked, so you don't have to type them down or something like that. And please, after the talk, feel very free to talk to me about all this stuff or just other stuff in general, like XR, VR, or in general, open source in general, and also especially about joining Collabora. We are always looking for people to join, even in these times. So starting off, what is AR and VR? What is augmented reality? So, a simple definition of the word augment means make things greater or add to it. So that's what AR is. And this is like a use case or an example of AR where the hardware is DAQRI. They had, unfortunately, they have gone under, but they had a very cool product where you would put on these headsets and a operator somewhere else in the world could call into the headset, and you would see, like he's seeing in this picture, the face of the operator talking to him. The operator could see what he was seeing, and it could also also draw onto reality. So if you see this little red circle here, that is actually drawn by this guy in this guy's view. So he's actually seeing it. So one of the use cases there that could have, like, you have this very complex machinery and there's like two guys in the world that could repair it, but you can call this guy, and the guy that actually is on the scene could put on these headset, and the guy could say, screw this bolt, like this bolt, and do not screw this bolt because then the whole thing will blow up, or something similar. Or like more sensible, pull this hard disk, don't pull this hard disk because then the server goes down, or something like that. So that's an actual work use case, I would say, for AR. But what we are more known, since this is a gaming focused conference, we're more into games, and I think the most widespread, commonly thought AR game out there is Pokemon Go, which is a lot of people say that's not really AR, but it's the most common AR game that like everybody has actually used, even though it's very limited in its AR-ness of the world. That's still classified as AR. And what is virtual reality? I really like this quote. I had to look it up because I first thought it was something that Adam Savage says, but it's actually from a movie called Dungeon Master. And that's Adam Savage's very famous quote, "I react to reality and substitute my own." And that's basically what virtual reality is. You completely replace the reality around you with something else. And again, the most common use case here that most people have run into is games. This is Job Simulator. But if you're looking at the absolute strict definition of AR, or sorry, VR, this is also VR. Even though it's not as immersive, it's still completely replacing the reality with something else, or a generated reality. So even Doom back in 90 whatever-ish was actually VR, even though that's not how it's VR is used anymore. So that was quick about what AR and VR is. So I'm going to talk about a little bit about OpenXR. So how do we do VR or AR or XR, as they're both commonly known together? You have your program, you have a sort of a software platform that sits in between, and then you have your hardware that that platform talk to. So you have your drivers, you have all that stuff. And example of platforms are Oculus Quest or Steam VR. And between the program and the platform, there's an API. And in the past, there was a lot of different APIs, and if you wanted to write your game or even on WebXR or something like that, the browsers or the games or the applications had to support all of these APIs all of these different APIs if they wanted to support lots of hardware, which just resulted in people that is supporting just one or two, and a lot of platforms didn't get as widespread usage support as they could have. So the solution to this is creating a new API, not like the XCD comic, where we have OpenXR, where there's one unified application interface that all of these platforms provide, and you can write portable applications that can now support multiple hardware. And participation in this OpenXR, there's a lot of companies, so there's actually all of the important players are there. It's like even Blender, and where are we? Yeah. So what is cool about OpenXR? It's just like OpenGL and Vulkan. It's made by Khronos. It is out now. You can actually use it. It's action-based, and that's a different interpretation of how to do inputs, and I will go a little bit into that. And there are FOSS implementations, which I will talk about a little bit later. But yeah, the key important bits here is that anybody can implement it. And just like OpenGL and Vulkan, it allows applications to be portable. So what does action-based mean in this for the API? So a lot of, in the past, you would, look on a controller, like is the user pressing the A button, or is the user pressing the B button, or pressing forward or moving forward, or angling the joystick in certain ways, and those inputs will be very tied to the type of controller because of that. So instead of, and that makes it hard to add new type of controllers, or which resulted in the past that basically every controller now looks like the Xbox controller, because that's the controller that most games were written for. But instead, if you think of inputs as actions, so you would an application would create an action saying teleport or fire a gun, and then just say maybe you can use the A button for this, or maybe you can use the B button for this. It's up to you. You have a lot more greater flexibility in remapping inputs, and also a lot greater flexibility of contextually changing the mappings. So say if you have a disability where you can't really, where depending on what you're doing in the application, you might not want to press the A button in the same way. And with actions, the application say now, I'm doing these actions, like I'm firing, holding a gun. But if change your weapons to say a sword, the game can now say I'm now holding a sword, and you can then remap the actions to different inputs allow for a lot better, both for new hardware and for allowing more accessibility options. So, and I think that's a really good thing. So going to talk about Monado and deep dive there. And this is the FOSS implementation part of OpenXR that I had on the slide before. So going back again, so how do we do XR? You have your program, you have your platform, and you have your hardware. And Monado is a platform. So it's a collection of drivers and software that allows you to run a XR application, basically a VR application, on your computer or on a specific hardware. So diving in a little bit into Monado, splitting up all of the components into fairly broad terms, as you might say. You have the OpenXR state tracker that sits on top, and that takes care of all of the state and all of the application interactions with the hardware, and abstracts away and simplifies them, and also do all of the error checking and all that stuff that's needed on behalf of the drivers. And then it calls down into Monado itself, the hardware drivers, the compositor, and the platform code. But yeah, that picture that I showed before is simplified, as I said. And even this picture is kind of simplified, but you can see that the drivers need to talk to the platform code that abstracts away the operating system. There are various levels of compositors, so we need to be able to support both OpenGL and Vulkan graphics API, and the compositor is basically graphics API dependent. So those interfaces are different there. And the compositor just needs to talk to the drivers in order to know how to do the hardware distortion on the HMDs. There's a whole bunch of auxiliary code here on the side that the drivers and all of the other parts talk to, and stuff like that. So analyzing it a little bit more on a little bit different site, you can see that these are the interfaces, and that there are certain interfaces in the stack. So you have your OpenXR here, you have the prober, which we kind of a misname, but it's called that, and that mostly probes for devices, that talks to the various platform codes. You have your XRT device, which is a device that the drivers implement. You have the XRT compositor, which implements the compositors and talk to both hardware via Vulkan and OpenGL, and also the underlying system. So it talks to X or Wayland in order to get access to the display system. There's also, adding more complexity to this, there's also an IPC layer that we insert between all of this. So you can run multiple applications. So you run the compositor in one process and then connect to it via the IPC layer. And the IPC layer just implements the same interfaces as the system underneath. So it's sort of invisible to the OpenXR state tracker that sits on top of it. So it's just a sort of a layer, basically. And what was all of this XRT I kept talking about? In Monado, we have the XRT interface, or the Monado interfaces. So those are all of these XRT device, XRT things that sits between the different components. It's purely C, is not stable. And this is, if you ever seen a talk about Mesa talking about the gallium interfaces, this is basically the same thing, but for XR. Its design is heavily drawn from gallium, and as I came from tungsten graphics, I was slightly, had a little bit of a hand in the gallium interfaces as well. So yeah, we drew a lot of inspiration from that, and just in general mindset about it. And again, it's not stable by design, because our understanding of hardware will change as we go along. Like, I never claimed to know everything about XR hardware in the past, and I'm not claiming that now. And we cannot predict the future, so we need to be able to change the interfaces as we go along. But luckily, we have the OpenXR interface that sits on top that is stable, and so application doesn't have to rewrite every 5 months or so. So deep diving a little bit more into all of these various interfaces, just to give some more meat on the bone. We have the XRT device, which is basically the most central thing, because this is the thing that's the XR hardware. You have HMDs, you have controllers. It uses some more aspect patterns instead of regular inheritance model like you would expect from Java. So you can sort of an HMD, or like a device can be an HMD and also have inputs. It could have hand trackings and be an HMD, and it doesn't have to have an HMD. So there's no, they just have different aspects that they can implement. There's various functions which allow you to synchronize the input, get the input, set output, so you can vibrate your controller, you can retrieve the positional tracking, and we also just recently added hand tracking, so you can get that from the device. And you also have like a fixed set of information about the hardware, so you can get the screen position, this distortion, what origin it is in the tracking system, or you can have various tracking system all combined. So this is also an information that's there. Then we have the compositors. Not to be, if you're coming from like an X and Wayland world, there's a lot of things called compositors nowadays, but it really only it does the same thing, but it's not also not designed to be user implementable in a way. It's more of a, I have this hardware, and this hardware looks differently, and having to add support for all of these various weird hardware and is really hard. So we actually need to push some of the compositing into the hardware. And you have a base class, and then the various classes for the different types of APIs and FD. So you have GL, you have Vulkan, and you also have FD, which is the basically DMA buff, or how to just raw buffer going over. And as we said, the FD compositor is the real compositor. There's also swap chains, which correlates basically one-to-one to the swap chains that is in the OpenXR API. It has more functions. It's more explicit, again, because the OpenXR state tracker that sits above this takes care of any implicit states and turn them into explicit states or function calls, which makes it easier to implement the compositor, and we push all the complexity up into the state tracker that sits between all of these, the important code and the application. then we have the prober, and it's the thing that actually is sort of become where we dump all of the functionality that's not really fits into all of, any of the other buckets. So it holds the policy, it probes all the devices that are on the system. I also abstract away some of the OS things on how to talk to hardware. We probably should split it into 2 parts. We've been thinking about that for a while. So I sort of a status on Monado and a little bit on OpenXR. Recent developments. We are passing the OpenXR conformance test suite. We are not conformant because that requires us to, pay the conformance fee. But luckily, the OpenXR conformance test suite is open source and readily available. We have packages in Debian for Monado, and unfortunately, Monado is in heavy development, so like even after a week, it's kind of out of date. We do build Debian packages on the CI, so you can point directly at the CI and download the packages there. We have 6-off tracking with the libsurvive project. We have an initial port to Android of Monado, so you can run Monado on Android, which is cool. We can do multiple clients. We have also added more drivers as we have gone along. Yeah, sorry about all of them. Oh, okay. Good. Yeah. Yeah. So this is the current list of hardware that we support. We support Android hardware, which is basically just the IMU in your phone and the distortion parameters from cardboard. We have a Arduino driver, which is sort of there as a example of how to create your own hardware with Arduino. There's also support for the Daedric controller. We have support for the OSVR HDK, Vive, Vipro, Index, and as I said, we are positional tracking through libsurvive. We support the Northstar headset, which is a really cool AR headset that's completely made by the community, so it's all open source. Very good fit. We have support for the PlayStation VR and the PlayStation Move. We have 6-off tracking there. It's a little bit tricky to set up, but you can actually get 6-off tracking with all of these. We have support for the really old Razer Hydra, and we do have a wrapper around OpenHMD, so we have support for those drivers as well. That's all in there. There are also some other drivers. We have a dummy driver that allows you to just test it even without allows you to test Monado without any hardware at all. We have a simulator driver as well, which allows you to connect into it and manually manipulate values to just simulate a hardware. And drummer drive is supposed to be as simple as possible, so which is why we have a simulator driver there as well, because it's slightly more complex. So you can look at the drummer driver of how to do a driver, or how to just start doing a driver where the simulated driver would sort of get in the way of that, all this crazy stuff that it does. Some code status. You can see Monado, the code that we have written for Monado is around 65,000 lines of code. There's 14K lines in the drivers. You can see that's fairly small to the rest of the stuff that's in Monado. They have the state trackers, which both is the OpenXR state tracker and the prober. There's some debug UI as well in there. The compositor. There's a whole bunch of auxiliary code that's there to make it easy to write drivers. We have the IPC layers. And if you're wondering why these are strike through numbers before them. Those are I sort of have kept this code page along from my various talks, and I keep updating them. So I think the first number is somewhere last year, and I think the second number is in February this year. So, and the RPC layer is new, so it doesn't have more numbers. You can see that the VI driver has grown a fair bit, and that's because we have added support for the index controllers, the index. We have hand tracking via the index controllers there as well. So that's all of that code that's there. And now a little bit about OpenXR. So apps and engines are starting to support OpenXR, which is good. The Godot has a OpenXR plugin that was made by Christoph Hag, a colleague of mine in Collabora. Lover, I added support for this and it's upstreamed, so that's a Lua game engine development system. And there's support in Unreal, and Unity has said that they will support them as well. So support is getting there soon. So next up for Monado, we want to improve the PS move tracking a little bit more. There's things that we can improve there. We also want to make a native lighthouse tracking inside of Monado. Sort of take the pieces that we need, and so we don't have to. So we can get a much better support in there. We want excellent North Star support, so we want to make North Star be really well supported in Monado. So just because it's an open source project, and we want to support open source brethren. Finish the Android port and also finish the Windows port, which might not be so interesting for you, but it will allow people to use Monaro everywhere, basically. Even further out, we are thinking on like system UI, setup UI, AR and SLAM. Those are things like, basically if you haven't used Steam, the Steam VR interfaces we need for Monado as well. We will probably just make a very simple one for ourselves for Monado, and instead provide libraries to do the thing. So GNOME and KDE can make their own system UIs for Monado, and so you can match the theme of the system UI with your desktop. To wrap up a little bit here. We are hoping to build a ForceXR, a open source community around Monado, but not just Monado, even like North Star and all those things. You are definitely welcome to join the various channels of where you can reach us for Monado as well. We want to make sure that open source is part of the coming AR revolution. At any moment now, and that is why Collabora has spent a lot of time and effort into making sure that Monado is there, and that there are open source alternatives to all of these through AR technologies, so that we don't end up in a walled garden again like iOS and Android. And a whole bunch of links for people to follow. You don't need to type this down. I will make sure that the PDF is available to download. So that's it for me. Again, feel free to talk to me about these things. And if you have any questions, please feel free to ask.
Okay, let's go to the first questions. Are there any flaws VR AR games using Monado or OpenXR yet?
Yes. Let's see. There's a port of the Morrowind engine. I have to. Let's see. The Dark Mode VR and Open Morrowind are two that has been ported to OpenXR and can be run on Monado. So, and there's support in the Godot engine. So if want, as people make their VR games with that engine, they will be able to support OpenXR and Monado with that.
Great. What is the minimal hardware to try OpenXR and apps?
Sorry, what's the?
What is the minimal hardware to try OpenXR and apps?
So you can run Monado without any hardware at all. We have the the simulator and the dummy driver, but you can't really do much then. Yeah. There's that's a hard question. What the minimal is? I think right now the best supported to give you a best or a usable system would be a Vive or Index, which is not very minimal, unfortunately. Yeah.
Okay. What is the relationship with OpenXR and WebXR layer?
So WebXR is sort of a different a different standard, and they were sort of made at the same time, but at different sites. WebXR runs on top of OpenXR, so Chrome implements its WebXR layer with OpenXR. Yeah. So in the simplest term, WebXR runs on top of OpenXR. So yeah.
Can you list classes of accessories that could be part to OpenXR?
Sure. There's a whole bunch of them. In a sense, as we expand the OpenXR API, and this is talking very high level, we would track more and more of the human body and more of the world. So any accessory that allows you to track, say, your hand, your face, or anything that can track and generate input. So like in the future, you can track your whole body, you can track your hands, and stuff like that. So like it's basically anything can be an accessory in that sense, but like in short term, a controller, we're hoping at some point to have good keyboard input. But yeah, like trackers for your body is basically, I think, the next steps, and also trackers for the world.
Okay. Headsets like the Oculus Rift require expensive PC hardware for nice graphical quality, but that aside, can someone get into PC-based VR and XR for less than 200 United States dollars? Is the North Star project going to be good for that end? And are there any other options on the horizon?
$300 is hard, or $200 is hard. eBay is probably your best friend if that's what you're looking for. So you can probably get Winamar headsets and such used for that around there. The North Star will hopefully be good for that. It's still a bit expensive, and even if you just buy the parts and 3D print other things, it takes a lot of time and effort to do. So I don't think it will be. It's hard to get under $200, just because of the screens and lenses and all of that stuff. there are, and you know, you're starting to get into territories where you skip 6-DoF tracking, and is that really a good quality, good quality experience for users then? Which is, yeah. So, but the North Star is good because it can, it's will hopefully lower the barrier of entry, but at least, but it also allows us to actually be in the game, so we can actually using only open source methods, experiment with OpenAR or OpenXR or AR in general. But yeah, it's a bit expensive, and the hardware that is cheap is, you know, not the best, and you also unfortunately need like a computer on top of that. So yeah, looking at like used WinMR headsets, like the first generation, while crappy, they still work, and hopefully at sometime next year we will actually have support for them in Monado as well, not just 3-DoF but actually 6-DoF.
Okay, the next one, is display audio the only output, or are there other actuators to target other senses like vibration or smell?
Yeah, currently in the OpenXR API, you only have display and vibration. So you have like vibrations in the controllers. But there's definitely room to add more. Like there's not in OpenXR yet, but like tactile feedback, so you can have special gloves that, you know, you can feel the stuff they're touching or getting, or feeling like you're actually holding something in your hand, like a gun or something. You're feeling the recoil. You know, there's a lot of research and development going on all around XR in general. But right now in OpenXR, vibrations, sound, and display is basically the only thing there. But you can extend OpenXR with extensions, so you can add support for more.
Good. Okay, let's wait if someone else
Yeah, there's
would
things
like
like,
to add more questions.
yeah. Then there's like feedback. I've seen people have vests with various various vibrations and stuff like that, so you can feel like you're getting heat shot and stuff like that. So there's a whole bunch of stuff to add more reality to it.
Okay, we have, well, someone was writing. Let's see if we have another question before finish. Okay, it seems this is everything.
Okay.
Thanks a lot,
Yeah.
Jakob.
Thank you. Thank you for having me. And have a pleasant evening.
Yeah, have a nice evening.